So there is this very simple term called constant velocity. Simple, so simple you might think it's not really worth discussing, but we need to. There are a few things you need to know about it. One way of describing constant velocity is by saying it's the opposite of accelerating. Now, acceleration, as you may recall, is a change in velocity, or any change in velocity. And as you recall, velocity has speed and direction. So any change here, and there are two kinds, speeding up, slowing down, they're both acceleration. Direction, simply a change of direction, is also acceleration. Now, when you probably came into this course, you probably thought acceleration was simply speeding up, but I hope you know by now there's three things: slowing down and change in direction, any change in velocity, three ways to accelerate. Here's some examples. I think you know by now this dropping ball is accelerating, isn't he, as he falls? Isn't he accelerating, speeding up at 10 meters per second squared? That's speeding up. This guy's hit the brakes on with his feet. His car is slowing down. That's acceleration. And of course, this car here is turning, changing direction. It's also acceleration. Now, constant velocity is the opposite, right? As I said earlier. So it means no change in velocity, not rocket science. Speed, not changing. It's not speeding up, and it's not slowing down, is it? And direction, we're not changing direction. That means going in a straight line, doesn't it? So here are two examples of constant velocity. This car is going straight on that straight road, and there's nothing to indicate that that velocity is changing, that speed is changing. So we'll say that is car has constant velocity, constant speed, going in a straight line. This person is playing baseball. He's just walked. It means he's gotten four balls, and now he's walking straight down to first base, right in that base path at a constant four. He's also displaying constant velocity, isn't he? How about this zebra here? What is he? He's stationary. Is his speed changing? Nope. How about his direction? Again, no. So stationary is an example of constant velocity, isn't it? All right, now recall back to Newton's second law. What causes acceleration? Well, force causes it. So here's a ball in outer space. He's going 5 meters per second. Out there's no force on him at all, is there? No gravity, no friction. Down here we have a ball also going 5 meters per second, but he's on a surface. So there is some friction, there is a force. So which one of these is going to continue in constant motion and which is going to accelerate? Well, there's no force here. This guy here is going to keep going 5 meters per second forever, basically. No force, constant motion. Down here, though, there is some friction here. There is a force. He will accelerate, in this case, slow down, correct? He'll go from 5 down to 2 because there's a force. Basically, if an object is moving and there's no force exerted on it, he will continue in constant velocity forever until there is a force. So there you go, constant velocity. You probably should write down this video code. You may need it. Got it? Video code. Bye.